I can begin. The environmental compartment are characterized by the presence of metal traces that are influenced by natural factors and as well with anthropogenic input. The various mineral elements are essential for health, survival, and if ingested in excessive dose, or if they can be toxic like heavy metals, they can cause serious damage and be lethal. The mineral elements that you can see in this slide, such as, for example, aluminium, arsenic, cadmium, mercury, or lead, are widely recognized and have an important biological action. Many metals are considered essential elements for biological function, and for example, as cofactor for enzymatic reaction or constituent for of the protein, such as copper, manganese, and zinc. Minerals are essential trace element for the survival or living being, and can be divided in on the basis of their body concentration. You can see I focus my presentation in two of these heavy metals that I study and presented my study later, that are mercury and cadmium. The minerals can be divided on the, of course, body concentration of macro and micro minerals, and their physiological value are exceeded and become toxic for the organism themselves, of course. The diffusion and the stability of the mineral elements in the environment make them unique and as related, of course, for the pollutants, and can be in some case essential for the dietary components. There are neither created nor destroyed, of course, by chemical process, but can be redistributed in the environment, and the amount of the mineral elements in the water and plant is influenced by the composition of the atmosphere. In the recent years, atmospheric composition by urbanization and, of course, industrialization, and the use of for example, chemical fertilizers and soil correctivers. There are a lot of compounds and metal alloys that with other elements that are essential materials in the contemporary world. Trace minerals play a vital role in the health of the development of a lot of class of animals. One of them that are, of course, the object of my presentation and my study, the horses, that some are contained in grass. This mineral are contained in grass, and while other can be adapted or supplemented in the food, for example, cereal product, and provide one of more of other nutrients. One of these heavy metal that I presented in this presentation is cadmium. Cadmium is more important and mostly is found in horses on the pasture fertility and the rock phosphate. Also, cadmium can be present and found in several sludge and has been used as a fertilizer, and it can be accumulated in plant, in grasses, and can be the source, of course, of the horses. Old horses have been found to present a high level of cadmium in organ, for example, in kidney, and high level of cadmium can be related to toxicity for this kind of animals, and can conduct to several damage and injury that can be affected several organ and system. For example, respiratory system that related to pneumatitis that conduct to a destruction of the mucous membranes, or other system like reproductive system that conduct to testicular necrosis, or kidney that we talk later with an show proteinuria, kidney stone, or more important, glomerular and tubular damage. But cadmium is important, and in horses more important for the involvement of the skeletal system that can conduct to the loss of bone density and mineralization, and in the severe cases can conduct to arthropathy or osteoporosis that are more important for this kind of animals that in a lot of cases are related to athletic competition. The other heavy metal that I show in my presentation is mercury. Mercury is mimic and smelting areas, can be presented in and using in fuel combustion, are present in pesticides, herbicides, and fungicides. Mercury in the typology of metal mercury and dimethyl mercury are more present in fish tissue, and are of course important source of food that if is poisoning can hit pets, and can be present of course in the diet in fish. Horses that living near farm are involvement in a potentially, of course, mercury poisoning, and related, of course, to the toxicity of these minerals. Horses that drinking river water in intensive farm areas were found to have highest level of these minerals. Mercury can show several different symptomatology, because can involve several organ and system, like nervous system damage, muscle spasm, or can conduct to a loss of weight that are related to colics, of course, in diarrhea. So can involvement organ for the nervous system, or other organ like the gastrointestinal. The gastrointestinal system. Mercury, when toxic, when are ingested in horse, and in some case the extensive organ-specific damage overshadow the gastrointestinal lesion, because the interest is focusing to the other organ, but the intestinal lesions are therefore overlooked. Mercury, like the other heavy metals, produce in the gastrointestinal system several lesions that conduct to colic or hemorrhagic enteritis. However, the most related injury for the intoxication by mercury is the neurologic disease, and in other case the nephrosis with the involvement of the kidney, of course. And this making the intestinal lesion seems minor in comparison, of course. Mercury poisoning is uncommon today. Its toxicity is well known, and its use has been discontinued, of course, for this discovered, and are less than the past, are less present in medicinal manufacturing and industrial processes. In our study, we focusing our interest to the presence of these two heavy metals in athletic course. This athletic course was placed in a city near Messina, here in Sicily, and is a city that are a lot of present of industrialization. This is a preliminary data we conducted with the agree of the ethical commission of our university. These animals that are, of course, athletic course are in the range of from 8 and 11 years old, and all of these animals follow the same program for 2 and 3 weeks. After these 2 weeks, we collected the biological substrate that was serum, and after divided in serum and whole blood, and because we focusing our study to see the potentially expression of these two minerals in these two biological substrate, because we thinking, of course, that can be a different expression of this compound and can be related to the pollution of the place that are placed, of course, these animals. You can see in this slide that after the collection of the blood, we divided in serum and whole blood, and we used the spectrometry for the determination of cadmium. Different determination was conducted with another instrument that was the DMA-AT. That is specific for the analysis of the mercury, and in fact you can analyze with this instrument mercury from solid, liquid, and vapor samples. After collected of course, the biological substrate, that in this case was the blood, and determination with these two instruments, we based our study to previous study. For example, you can see the our university, and in this case we see the bioaccumulation of several minerals in different biological substrate, and it was similar to our results. In fact, in this case, the athletic course placed here in the same place, Messina, with a lot of excessive, of course, industrialization, to see the different expression in different biological substrate. And we can see in this slide that the level of cadmium in serum and whole blood was positively correlated with the statistical analysis, person statistical analysis, indicated that there are a positively involvement in correlation from serum and whole blood for cadmium in this paper. And we conduct a similar analysis for for blood and serum of cadmium, but we see in our cases that this animal that was yeah, it was in the same place, not presented a positive correlation regarding cadmium expression in serum and blood. Another paper show the different expression of the mercury level in several biological substrate that was serum and whole blood, and other, for example, the hair of the animals that can be used for uh, for the biological analysis. And in this case, that was see that mercury not presented for the athletic course from Messina, the same city, height level that can be reflected intoxicated condition for the animal, that was the value that was presented in the literature. Our study showed that the level of mercury for the athletic course of this animal that was placed near a farm, near a place with an oppressive industrialization, showed a positive correlation. You can see that the value of Pearson was so near to the one, so are positively correlation from serum and blood that is different to the other results that we obtained with cadmium, that was a negative correlation. So after this, we got to see the different expression in blood and serum of mercury and cadmium, and we focusing to the expression, and we see that there was a different trend. Strange is that we can see a inversely expression of these two mineral level from blood and serum, but we can show this with these results that, for example, mercury are more expressed in blood than in serum, and opposite situation is presented by the cadmium level. So we can affirm with this data that for the biological blood is more near to can use for the biological substrate of mercury, and while for cadmium we can see that serum is better than blood for an potentially use for the biological analysis. So we can conclude that we see a positive linearity, and this is significant and positive and significant for mercury, but not for cadmium. Blood and serum that we use are expressed for athletic course that are potentially involvement in a pollution situation caused for the excessive industrialization. Another conclusion that we can affirm that maybe in the future can be interested to evaluate the concentration of mercury, for example, in other biological substrate, for example, tail or hair, that are more indicative for horses and, of course, athletic horses. And at the end, the possible bioaccumulation of mercury might show a correlation between the hematological parameters of blood mercury concentration in horse. Thank you for your attention.